Hello students, today's class is all about Wallace line, discontinuous distribution and continental drift. So, we are going to talk about what is this Wallace line all about and discontinuous distribution of the animals on this planet, and the continental drift, that is how the continents have drifted to what it is looking in the present day. So, what is this Wallace line and who was the scientist who had prepared this Wallace line to us? Alfred Russel Wallace, a British naturalist, explorer, biologist and social activist, is best known for proposing theory of natural selection along with Charles Darwin's idea, and they both published a book in 1858. From 1854 to 1862, Wallace trekked the Malay archipelago, today's Indonesia, wallowing in its wildlife. What is this Malay archipelago? The islands that are present in the regions around the Malaysia is called Malay archipelago. Situated on the equator and surrounded by three great tropical oceans, this area is of 13,000 islands, displayed an unheard of wonderful variety of species. So, because it displayed an unheard variety of species, Wallace got really interested in this particular archipelago. While in Indonesia, he drew a Wallace line which divides Indonesia into two parts. The term Wallace line was first used by Huxley in 1868. Wallace line is a faunal boundary line drawn in 1859 by the British naturalist Alfred Russel Wallace that separates the biogeographical realms of Asia and Wallacea, a transitional zone between Asia and Australia, also called as Malay archipelago, and the Indo-Australian archipelago. So, this is the Australian archipelago and this is the Asian archipelago onto the other side. Wallace noticed this clear division in both land mammals and birds during his travel through the East Indies in the 19th century. Now, what is this Wallace line? It represents a geographical separation between the Sunda and the Sahul regions of Asia and Australia faunas. A collision of the tectonic plates brought formerly distant land masses closer together. The Wallace line is an imaginary line that intersects the Lombok Strait between Indonesia islands of the Bali and the Lombok. So, if you can see, this is the Bali over there and this is a Lombok, and this is an imaginary line that separates the Bali and the Lombok to the south and extends north through the Makassar Strait. So, it extends to the Makassar Strait on the north between Kalimantan, that is the Borneo, and Sulawesi onto the either side. The distance between Bali and Lombok over here is just about 35 kilometers. Now, if it is just about 35 kilometers, we can expect that both the fauna should be the same on either side, but it is not so. The Bali had its own fauna and the Lombok had its own fauna, and these two islands were separated by the ocean with just 35 kilometers, and still they had different in the faunals. The root cause of the faunal line is that the ancient supercontinent Gondwana was separated entirely from other parts of the world after Pangaea broke up. Australasia and its smaller islands were part of Gondwana, and that is why their fauna is so different from that of southeast. So, the whole continent that were united is called the Pangaea over here, and when they separated, they look like two different continents like Laurasia and Gondwana, and this is the present continent that it is looking like over here. So, the Wallace line is used to mark the difference between species found in Australia, New Guinea on one side and southeast on the other side. This apparent when considering the difference in the mammals between these two regions. That is, the south and the east line marsupials and monotremes are found, that is the marsupials, the pouched mammals, and the egg laying mammals, the monotremes, are found, unlike the placental mammals that is found in the north and the west of it. Because of the complexity of the geographical landscape and the differences in diversity of organisms around the archipelago, continuous attempts to characterize faunal and botanical boundaries were carried out after Wallace, and some of them were this is what the Wallace line is all about over here, that is separating the Bali and the Lombok over there. But later on Huxley put the line a little bit beyond, that is separating the Palawan with that of the other smaller islands on the either side. And later on Weber's line came up in 1919, and on the same line Mayer's line had come up, and also the Lydeker's line, that is a little beyond the Wallace line towards the east side of it. Now, biogeography of understanding the region centers on the relationship of ancient sea level to the continental shelf. Wallace line is visible geographically when the continental shelf contours are examined. So, if you can see the contours of them. It figures as a deep water channel that separates the southeastern edge of the Sunda from that of the Sahul shelf. The Sahul is the Australian shelf. The Sunda shelf links Borneo, Bali, Java and Sumatra underwater to the mainland of the Southeast Asia, while the Sahul shelf connects the Australia to the New Guinea and their adjacent islands. So, this is the Wallace line which separates them, the Sunda on the other side and the Sahul on the eastern side. During the Pleistocene age, that is the Pleistocene age means the ice age, when the ocean levels were up to 120 meters lower, islands became connected but never uniting Asia with Australia. Consequently, over 50 million years, deep water between these two large continental shelf areas created a barrier that kept the flora and fauna of Australia separated from those of Asia. It can reasonably concluded that it was an ocean barrier preventing species migration because physical aspects of the separated islands are very similar. What do you mean by this ocean barrier? When there is an ocean barrier, you cannot expect the animals to move from one area to another area because of the deep sea oceans, and even if they would have, they must have got extinct in that water. So, this barrier kept these two continents separated, and hence the difference in the fauna and the flora of these two continents. Thus, the Wallacea region consists of islands that remain isolated on respective continental land, with only those organisms capable of crossing the straits between island and populating them. If at all they were able to, they could just jump from one island to another island and populating them, but otherwise all the animals could not do so. Now, what are the fauna of Wallacea? So, what does Wallace find out the difference in the fauna? Out of many freshwater fishes on Borneo, none reaches the Celebes. So, Borneo is just over here and Celebes is just beside them, but none moved to that Celebes. And on a Java, there is a decrease in the fish fauna from the west to the east, and Bali does not have any significant fish fauna which is just beside the Java. Amphibians, oriental frogs and microhyla extend up till the Bali, Bufo to the Celebes over here, Bali and Lombok, and Rhacophorus to the Celebes and Timor. So, this is a Timor over there and that is a Celebes over there. There you can find the Timor. From Australian side, Leptodactyls reach New Guinea over there and Aru Islands. So, just beside that New Guinea you have the Aru Islands, and Hyla extends to Moluccas and Timor. So, this is Moluccas over there, just beside that Aru Islands over there, Moluccas and Timor over there. Fauna of the reptiles of the this Wallacea is majority of the oriental reptiles do not cross Wallace line and none extend beyond Weber's line. From the Australian side, only few snakes reach up to Moluccas. Aves, the distribution of birds is complex. Some of the oriental birds extend up to the New Guinea and some Australian species reach beyond the Wallace line because they were able to fly. 75% of the birds on the Lombok are oriental, some from the oriental region. They were able to fly till the Lombok region over there. But on Bali side, only 14.5% of Australian birds exist. So, from this they were not able to jump over here. From oriental they were able to fly. So, that is the reason why you find almost around 75% from the oriental region. Mammals, most of the oriental mammals stop on the Borneo over there, the Borneo and the Java. Very few reaching up till Celebes and the Bali, and none cross over to the Moluccas, because Moluccas is a little bit far away, and the lesser Sundas. The Australian mammals stop in New Guinea. So, Australia up till New Guinea they stop, and only a small fraction reach up till Aru Islands on the Kai Islands. Only one species, that is the flying phalanger, reaches Celebes and Timor. So, this is the flying phalanger which you can find in this picture, the Celebes and Timor, they were able to just fly over there. Coming to discontinuous distribution. So, that was about Wallace line, why he had drawn that line separating the archipelagos. Discontinuous distribution, that is all the animals are not continuously distributed, but they are discontinuous distribution. Why so? So, the distribution of the animals on the earth is not uniform or regular, and there are three to four main patterns of the animal distribution. So, what are they? They can be cosmopolitan distribution, they can be discontinuous distribution, they can be endemic distribution and bipolar distribution. What is cosmopolitan? Cosmopolitan is present everywhere, that is a few animals are distributed throughout the world in all climatic zone, or at least in one climatic zone of each continent. And these forms that enjoy the global distribution are said to have cosmopolitan distribution, that is they are found everywhere on the earth. Example, rat, hawks, cuckoo, earthworm, pigeons and so on. What is endemic distribution? Endemic is restricted only to that particular area. And for example, these are giraffes, which are confined to Africa only and are found nowhere else in the world. Thus, family of Giraffidae is referred to as endemic to Africa, and 90% of oceanic island fauna and flora consists of endemic species. What are the other examples? The kangaroos which are found only in the Australian region, Asiatic lion which is found only in India, and pandas which are found only in China. So, these animals are endemic to their respective climatic conditions. The next distribution is a bipolar distribution. Bipolar, that is which are found only in the polar regions. So, these are some animals that can be adapted to the cold Arctic climatic, hence restricted to the polar regions. Examples are polar bears, Arctic fox, lemmings, coyote and reindeers are found in the northern polar regions, while penguins are restricted to the Antarctica region, that is the southern polar region. Among fishes, salmons migrate up to the temperate and polar tributaries for just breeding purpose, then they come back to their respective places. And other polar species are coelentrates, mollusca and Urochordata. Discontinuous distribution. What is this discontinuous distribution? Some closely related species are found to inhabit one or more localized area which are widely separated by thousands of miles, but not present in the region between them. Such species are said to have discontinuous distribution. Now, if you can see this picture, Africa, you have some ostriches in Africa, but they are not found in the Asian country, again they are found in the Australian country, whereas the same thing happens, there is a discontinuous distribution between the sea, and then you have them present in South America, that is the Tinamous and the Rhea ostrich found in Africa, the South America, ostrich in Africa, cassowaries, emu and kiwi in the Australian regions. The reasons for discontinuous distributions. Animals reach distant areas by sweepstake routes, that is they can just be moving by flying or by rafting or by floating, like what the snails and the rats can do by rafting, turtles by floating, and birds blown by storms. The species was earlier distributed continuously, but the land masses in the intermediate area submerged, breaking the two species into widely separated population. Continental drift separated the continents and carried them to the long distance, isolating animals to that particular area. A widely distributed species can become extinct in the intermediate areas due to change in the climate to which the species is unable to adapt. Now, we will see a little bit of examples of these animals which are discontinuous distributions. Peripatus under phylum Onychophora has 75 species distributed in Southeast Asia, East Indies, Australia, New Zealand, Africa and South and Central America, but they are not found anywhere else. The three surviving genera of the lungfishes occur in three different countries: Protopterus in Africa, Lepidosiren in South America and Neoceratodus in Australia. So, these also show a good example of discontinuous distribution. Similarly, the limbless amphibians, the Apoda or Gymnophiona of the genera Ichthyophis, Giganophis and Dermophis occur in South Africa, South America, Central America, South Asia and East Indies, which is not found anywhere else. And the ostriches over here, which are distributed in the southern hemisphere, the Rhea americana in Argentina and Brazil, Strutiocamelus, that is the ostrich in Africa, Emu in Australia, Cassowaries in the North Queensland and New Guinea and Kiwi in the forest of New Zealand. Marsupials, which occur in Australia, but one family Didelphidae occurs in South America. So, you can see Australia over here and America over there, but these two countries have the marsupials and no other countries have the marsupials. And what are those that include in the South America? These are the opossum that are present in South America. The common camel, which occurs in the Middle East, India and Northern Africa, that is Camelus dromedarius. So, this is the picture of the Camelus dromedarius, whereas Camelus batrianus is found in Mongolia and China, while two species Lama vicuna and Lama gunaco are found in the mountain regions of South America. So, these are the discontinuous distributions of the camel. And of course, how can we forget the elephants over there? The Loxodonta africana occurs in Africa, while another species Elephas maximus is found in India, Burma, Thailand and Sri Lanka, although the names are different over there. The alligators that occur in America and China, Alligator mississippiensis in America, Cayman in South America and Alligator sinensis in China. So, again you can find the discontinuous distribution of these alligators. Now, coming to continental drift. So, that was about discontinuous distribution. We will talk a little bit about continental drift. So, what do you mean by this continental drift? Now, what you see in the present day where the continents are distributed, it was not so earlier. Some 225 million years ago, all the continents were attached as a complete continent, one big continent called as Pangaea, which later on during the time period got separated as what we are seeing nowadays. So, what it is and how they were able to come to a conclusion is what we are going to talk about in continental drift. The large scale horizontal movement of continents relative to one another and to the ocean basins during one or more episodes of geological time. This concept was an important precursor to the development of theory of plate tectonics. We will be talking about what plate tectonic is. The most recent idea of these supercontinents, Pangaea, formed around 200 to 270 million years ago and broke up about 200 million years. The theory that the present day position of continent is not permanent, but continents constantly drift and change position was proposed by Alfred Wegener in 1910. The earlier idea about continental drift, that is a century ago, two types of thoughts were prevailing in the geotectonics. One group said all continents and oceans are stable since their origin and they moved very little, while the other group was in a favor of large scale horizontal movement of continents. In 1596, Abraham Ortelius, a cartographer, suggested that the continents were separated by floods and earthquake. Later in 1620, Francis Bacon, an English scientist, proposed that Africa and South America were once joined together based on the similarities of their coastlines. A German geographer, Berhandus, in 1650 suggested that America and Europe were once a single continent. So, they were able to find out these continents were somehow attached together. Edwards was an Australian geologist in 1893 suggested that South America, Africa, Australia and India were connected together as a single supercontinent during the late Paleozoic era. He named the supercontinent as Gondwana land. So, you can see on the southern side there is a Gondwana land after the Gond tribe of the central India. So, the name came because of the tribes that were present in India, that is the Gond tribe. So, the name Gondwana land. In 1893, he also coined the term Tethys and Panthalassa. So, you can see the Tethys Sea over here and the Panthalassa Ocean surrounding the continent. The work of Edwards was laid a sound foundation to the continental drift hypothesis. So, from there the continental drift hypothesis started, and in 1910 Frank Taylor, an American geologist, envisioned that the continents were not stationary but moved laterally in geological past. Then came Wegener's hypothesis, that is Wegener's continental drift hypothesis. Alfred Lothar Wegener 1880 to 1930 was a German meteorologist, climatologist and geophysicist who is credited for formally developing continental drift hypothesis in 1912. His hypothesis was developed between 1908 and 1912 and is popularly known as Wegener's continental drift hypothesis. He published this hypothesis in his book The Origin of Continent and Ocean, of which 4 editions appeared during 1915 to 1928. So, according to his theory, all the continents were one single continental mass called Pangaea. So, you can see this is a one continental mass called Pangaea and a mega ocean surrounding the supercontinent. Now, what is this name of the mega ocean? That is the Panthalassa. So, all the blue color one is a Panthalassa and in between you can see a Tethys Sea. According to this theory, the supercontinent Pangaea began to split some 200 million years back. So, they were not constantly together, but they started splitting very slowly. So, how did Wegener say, or how did he prove his theory over here? His theory started late Paleozoic era, that is during the late Paleozoic era or the Permian period some 225 million years ago. The whole continents were attached together as a one large continent called Pangaea. Then during the Triassic and the Jurassic period, slowly, that is around 200 million years, the continents started to split and the splitting occurred with the Tethys Sea which over here. So, because of the Tethys Sea, the continents started to drift a little bit and they divided into 2 large continents, called the northern side, that the Laurasia continent, and on the southern side it is the Gondwana, that is Gondwana because of the Gond tribe in India. So, this particular small region that you can see over here, so this is India, the South America and the Africa over there, and the Antarctica and the Australian countries. And by 150 million years ago, you can see the separation being a little bit more further away, and by Cretaceous period, that is 65 million years ago, a further continental drift could be seen, and this is what the continents are in the present day. So, this is how he tried to propose his hypothesis, but he also had to prove and give some evidence, that is mechanism of drifting. How could the continents drift? Wegener thought that the oceans are composed of heavier materials than the continents. So, he deduced that the less dense continents are floating on the heavier subsurface. But as he knew that drifting would require enormous amount of energy, he attempted to attribute the drifting process to pole fleeing and external tidal force. So, he proposed there are two processes, that is pole fleeing and external tidal force. Wegener believed that the centrifugal force of the planet caused the supercontinent to break apart and pushed continent towards the equator. That is what is called as pole fleeing, that is the North Pole and South Pole. They were fleeing and they came together into the equatorial region. Therefore, he called this drifting mechanism as pole fleeing or centrifugal force. Now, what is tidal force? Wegener tried to attribute the westward drifting of the Americas to the lunar solar drag. So, you can see this is Africa, then South America being drifted towards the western side, and this he attributed to the lunar solar drag by invoking tidal force, which is gravitational force of the sun and the moon. He also admitted that it is probable that pole fleeing or centrifugal force and tidal force are responsible for the journey of the continents, that is continental drift. But he left many questions unanswered in the context to mechanism of drifting. People did not accept his hypothesis of pole drifting. So, he had to provide some more evidence for his pole drifting. So, what are the evidence? The first evidence he came up was the jigsaw fit, that is the shape matching fit is what is called as jigsaw fit. The coastlines of South America and Africa fronting each other have a remarkable and unique matches. So, that is the pole that is the jigsaw matching of the continents that you can find over here. The second evidence was the fossil plants, that is the Lithosaurus during the Triassic period. The fossils were found in India, Africa and Antarctica. As the same way, the Mesosaurus freshwater fossils were found in America and Africa, and the other fossil is the Cygnognathus that was found in America and Africa, and of course, some plants that is also found in the Gondwana island. Lemurs found in India and Madagascar and Africa validates that India was connected to Africa via Madagascar in the past. And also he also identified some of the Glossopteris plants that were found only in the Gondwana island, that is in Australia, Antarctica, India, Africa and America. Then the next evidence was the rock formations at numerous locations, that is Caledonian rock formations found in the northern Ireland, the Scotland, and in terms of age structure was matching with the Appalachians of the North America regions over there. Then he also found that Cape Fold Belt mountains found in Africa and South America, which matched with the age of that particular era of that period. Placer deposits. Now, what is a placer deposits? The presence of abundant placer deposits, this is the veins over there. Once the veins due to the volcanic eruption removes those placers around, it flows to another continents over there. So, because Africa and South America was close by, the presence of abundant placer deposits of gold along the Ghana coast and the complete lack of its source of rock was evident, and the gold bearing veins are present only in the Brazil, and is evident that the gold deposits of Ghana and Africa are obtained from the Brazilian plateau from the time when two continents were beside each other. The ice matches, that is the glaciers and the tillite, was also one of the evidence where the glaciers were found in the Gondwana islands, the distribution, and of course the tillites was also one of the evidence. The glacial tillites gave clear evidence for paleoclimates and drifting of continents. So, this is the presence of the tillites that is present in this particular regions over there. Bituminous coal, that is a coal, a fossil fuel which is made from the compressed remains, was discovered in South America, Africa, Indian subcontinent, Southeast Asia and also in Antarctica. Now, Antarctica is in the cold continent, but before it was in attached to this Gondwana period where the temperature was tropical, and hence you can find some of the fossilized coal over there. Although Wegener's evidence was sound, some of them were not able to accept it until 1950s. Later on, after 1950, new evidence about earth structure was caused, wherein the new evidence, paleomagnetic studies, appeared to provide support for Wegener's idea of continental drift. The continents appear to have joined over 200 million years ago, and paleomagnetic evidence also suggests the continents have moved northwards. So, this theory of continental drift was evidenced and supported by plate tectonics. What is plate tectonics? It's a theory which states that the Earth's outer shell is divided into several plates that glide over the mantle and the rocky inner layer above the core. The plate acts as a hard, rigid shell compared to Earth's mantle, and this is called as lithosphere. Oceanic ridges occur along some of the plate margins, where in this case the lithospheric plates separate, upwelling mantle materials forms a new ocean floor, and trailing edges. Now, what is this convention? Because of the core heat, they keep moving, thereby separating the land masses as divergence and convergence. Now, if you can see in the lithosphere rigid over here, there are three types: divergent, convergent and transformers. When the two rigid plates are diverging, that is separating away, you find the volcanic eruption at that area. Convergent is when the two plates come together, either there is a convergent of one land and the other land moving around, and when this happens with continent and continent, you have an upwelling mountain constructions, is what the example of Himalayas, that is a convergent. And during transform, when the two lands are moving separate against each other, is when we have earthquakes occurring. So, this explains the plate tectonics, and this explains how the continent must have drifted and what it is in this present period. So, this is what is all about continental drift. Thank you.